Okay, so this afternoon I want to provide you with the fundamental of the radar technology. I use radar in my research in AI for perception, and at Sensor Cortek we obviously also use radar for our embedded perception systems. It's a pretty dense presentation, so you might want to review my slides if you're interested by the subject, because I won't have time to cover everything, but I'll give you the essential of it. Radar, the first thing to say is that radar is a relatively old technology, very mature, reliable, and recently there's many new applications that have emerged. Occupancy detection, for example, gesture recognition, and obviously in the automotive space for ADAS and AV applications. For that reason, I would say almost every aspect of that technology have considerably improved over the recent year. The cost, the size, the power, every aspect of it. I mean, the radar is evolving rapidly. So I mentioned it's a pretty old technology. It is based on the electromagnetic wave. And these ones have been predicted by the Maxwell theory and demonstrated by Earth at the end of the 19th century. And interestingly, probably the first application of the radio wave was the radar. In fact, there was a demonstration of radar for detecting ships at a distance, and that first public demonstration was May 18, 1904, which is almost exactly 120 years ago. And obviously, the radar continued to evolve. It is based, the modern radar of today are based on three essential technologies: the time of flight, the continuous wave, the frequency modulation. That's why the modern radar are often called or designated as FMCW radar. So let's explain what these three elements are, three technology are.